It is one of the most common minerals within the Earth's crust, visible in use wherever you look. Silicon dioxide, also known as silica, is a compound so frequently used it would be hard to live without. Whilst we do not necessarily depend on its consumption, its presence in our daily lives is almost essential. Often we overlook the significance of some things in our lives as we have become accustomed to them from being exposed to them every second. Therefore, it is important to reflect and understand the significance of some of the most seemingly insignificant things in our lives. Silicon dioxide is such an example. Its main use in forming glass, the primary purpose of which is to be invisible. One would assume by its name, silicon dioxide, that it would form a molecule as such, one silicon atom and two oxygen atoms. However, in its simplest form, it forms a tetrahedron of one silicon atom and four oxygen atoms. Naturally, it forms large covalent structures of tetrahedron upon tetrahedron, this being a small example. This involves each silicon atom bonding to four oxygen atoms and each oxygen atom bonding to two silicon atoms. This gives a ratio of one silicon atom to two oxygen atoms, and thus the empirical formula SiO2. The formation of giant covalent structures of silicon dioxide means that as a whole it is quite strong and forms very hard substances, examples being the mineral quartz and our focus of glass. Diamond also exemplifies the strength of giant covalent structures, being the hardest known substance. Glass's signature value of transparency is a result of a few properties of silicon dioxide. Naturally, it forms crystalline atomic structures as seen in silicates such as quartz and sand. However, when making glass, these minerals are melted and the bonds are broken. The result is liquid silicon dioxide, with the minerals suspended in an unordered fashion. This is then cooled very quickly, and the molecules reform their bonds in their unordered positions. This forms what is known as an amorphous solid, with the hardness of a solid but the molecular disorder of a liquid. This is possible due to the ability of the SiO-Si bridges to form their angles from a range of 110 to 170 degrees with minimal bond energy change. Consequently, the covalent structures are slightly less compact than when in crystalline form, and light passes through easier. However, the main reason for transparency is that in order for a photon to be absorbed by a substance, the energy it is carrying must match the energy required for an electron to move up to a high energy level shell. Silicon dioxide does not absorb any photons within the visible spectrum of light. As a result, it is transparent. However, it does absorb UV light, which protects us from the sun. To conclude, I hope I have demonstrated the significance of silicon dioxide in our world. You might have noticed that glass featured in each scene of my presentation, proving its prominence in each of our lives. Glass is only one of the many uses of silicon dioxide in this world, showing that it is not only important to me, but to the whole world.